Well, thank you. Again, my name is Mike Stasiewicz. I want to thank you for inviting me here. This is my actually second time to Riga. Last time was about 15 years ago, in the middle of the summer. And what was interesting about Riga then was that it got dark at 1 a.m. and light at 3 a.m., which kind of freaked me out coming from Colorado. But this is a little bit different. Actually, the climate here is very similar to Denver right now from where I am. And so what I'm going to try to do is make this as entertaining as possible to you. My background with IBM is I'm an aircraft mechanic by trade, a licensed aircraft mechanic. I'm also a pilot. I used to work for the airlines. Used to work for GE Aircraft Engines as a technical writer. So I've got some pretty good understanding of the airline industry and, you know, what goes on with the airline industry. And what I want to do is kind of bring up this, let's see if I got this going here. There we go. So this first slide here, kind of a history of early aviation. A lot of you probably realize that Mr. Wilbur and Orville Wright are the ones that did the first human manned flight back in 1903. But I don't know if it's interesting to you, but as a person that has over 1.6 million miles on United Airlines, it's interesting to note that we've only been flying planes for, 100 and some odd years? And that plane there on your left is probably weighs about 600 pounds. Oops. That one there weighs, anybody want to guess what that Airbus A380 weighs at gross takeoff?
100 tons?
Higher. Higher. It's not 100 tons. 572 tons. It's over 1 million pounds. What do you, I mean, does that not boggle your mind that that thing can actually get up and 1 million pounds can lift off the ground and carry us for 15 hours from around the globe? It blows my mind, and I'm an aircraft mechanic and a pilot. I mean, it's just amazing what they're capable of doing. The engines on that plane, what's interesting is, you know, even though the plane weighs over 1 million pounds, each of those engines produces 100,000 pounds of thrust. So, okay, so there you go. 400,000 pounds of thrust that'll lift 1 million pounds of weight. When I used to work for GE Aircraft Engines, what was interesting is the GE90 engine, which is the big engine, the actual fan cowl, which is where they have the fan, you can actually put a 737 inside of it. It's that big. It's 10 feet in diameter. And what's interesting is about these engines is that they can be what's called derated. So let's say you want to buy an A380 with GE90 engines on it, but I only want to have it produce 90,000 pounds of thrust because it's actually cheaper that way. They'll actually sell it to me at only 90,000 pounds. So they'll derate it through software, so it only produces 90,000 pounds of thrust. But the engine's capable of producing 114,000 pounds of thrust. But it'll cost extra money to produce 114. But it's just a software change, right? that makes it do that. So it's pretty amazing some of the technology that goes into these engines and the airframes. And the other thing about these aircraft is they've got terabytes of information coming off of them. I mean, lots and lots and lots of sensors, data that comes off the aircraft. Okay. A lot of things that we have is some different views that go on is, you know, a customer view. You know, the perception of the customer, you know, comes down to, am I sitting in the back of the plane and do I have any entertainment going on around me? Right? Some of the, I don't know if you've seen it or not, because I live in America and they've been doing some changes. I got on a plane, an A320, it's a brand new one on United, and it absolutely had no entertainment at all. You got in the seat, there's no place to plug anything into, there's no monitors, there's nothing on the plane. going, what is going on? Well, what they're doing, the industry, is everybody already carries an iPhone or an iPad or a Samsung device or a laptop on board the plane. So why put all this entertainment stuff on the plane, which is heavy? Let's just don't even have it. And let people then hook up to the wireless network on the plane and hit the entertainment server. And that's what they're doing. So the industry is going to go to that very soon. If you've been on Lufthansa, Lufthansa planes, you can get their entertainment app on your iPhone or on your Android tablet or something like that, and you can stream movies right to that device while you're on the plane. But if they can take that technology off the plane, which is heavy technology, the old monitors and things like that, they lighten up the plane, which then gives them better fuel economy. Okay. Supply chain. So when you talk about supply chain, one of our customers is United Airlines again. Some of their problems are, I need to have the right parts in the right city when that plane has an AOG, aircraft on ground. How do I do that? How do I predict that when I'm in Moscow, and I had this problem, when I'm in Moscow and the brake indicator comes on and the closest part is in London. So I'm going to have to ground the plane and send everybody on that plane to a hotel. So I'm going to talk a little bit about predictive analytics and logistics and things like that. Because that's what it's all about. It's all about streamlining that supply chain that that customer has and having the right parts at the right time so they don't have to put up hundreds of people into a hotel. Okay. So talk about some of the global drivers. What's happening in this industry is we're becoming more global, right? Which means that we want to travel from point A to point B, and honestly, we don't want to be on that plane for a whole long period of time unless I have some good entertainment. Okay? So we're getting to the entertainment side of things. It's actually coming, movies and music and things like that on board the planes. It's really nice. The passenger growth, it's only getting bigger. People are wanting to travel. India is one of the biggest boon countries in the world for airline growth. There are airlines that are starting up, but they're all in the India area and the Asia Pacific area. So there is still a lot of growth of these small airlines to support that need of the traveling public. Globalization, which also focuses into everything I've already talked about. It's a big global world here. It's all one big family. I travel here in 12 hours. You could go anywhere in 12 hours. It doesn't take long to get from point A to point B. With some of our technology improvements, these aircraft, have GPS on board. And that GPS gives us a lot of different information. And whether or not they actually utilize that information is another thing. Because like I said before, these newer aircrafts, the A380s, the 787s, Dreamliner, terabytes of information that come off those aircraft, but a lot of times they don't know what to do with it because it's so much information, right? So you have to have some kind of means of either some kind of analytics or data store that I could then see and then analyze that data to see if I can predict when some kind of component would fail. Okay. So some of the challenges are the capacity and congestion. When you think about congestion, airports are getting pretty crowded. Some of the airports are starting to expand. I think London Heathrow is looking to build another runway just because of capacity. I live in Denver, but we have Denver International Airport, and that's actually probably the youngest airport in America. It was built 20 years ago. And it is actually, I don't know if anybody's been to the Denver area or not, but it's actually what I call, it's out in Kansas. It's so far away from the rest of the city. It's out in the flatlands. The original airport, which was called Stapleton, was kind of in the downtown part of the city. So they built it and they put it pretty far out. And there's really no homes around it. So there's no real houses being built or anything like that. I mean, things are getting closer. They're just now putting in commuter rail to the airport. So they do finally see that need after 20 years that people want to take something other than their car or Uber to the airport. Empowered customers, efficient green operations, safety and security. There's all kinds of things that go around flight operations and airlines. You probably don't realize it, but aircraft are up 99.9% of the time. That's their efficiency rate. Planes, you just don't hear of planes failing anymore. You know, AOGs, problems at the airport because of a defect or something like that. When you look at the whole grand scheme of things, that's hardly anything. 99.9% of the time these aircraft are flying. Okay, and I'll tell you an interesting story because my brother-in-law is a KC-135 tanker pilot in the U.S. Air Force. And the thing about those planes is they're close to 50 years old now. And these planes, all planes, will last 50 plus years if you want them to. Honestly, you could keep flying them and keep maintaining them for as long as the plane would do it. I mean, they're so rigorously maintained that there is no stopping how long and how old an aircraft could be. A lot of times it's the perception of the technology when somebody gets on board the plane. You probably don't realize that this thing might be 24 years old, 25 years old. You know, the A320s, they're 24, 25 years old now. They're still building them, but you never know if you get on one that it might actually be 24, 25 years old, which is probably older than some people here, I would think. You might have heard of what's called an ARC report. These ARC reports are produced from the industry, and IBM's really big into the thing what's called the Internet of Things right now. Now, what that means to us as an IBM company is that we understand that there's all types of data that comes off of these complex assets, not just aircraft, rail cars, automobiles like we talked about this morning. Lots and lots of data comes off these cars and off these planes. And what they're seeing is that if we take that data, there's a way to take that data and then do analytics on it, maybe we can offer other services or have better safety for that asset, that flying asset in my case. Okay. So what they're doing is they're looking right now, IBM is very heavy into doing what's called condition-based maintenance operations. So if you can set up a condition-based maintenance for your aircraft, and you can actually get that telemetry data off the aircraft that says that once I hit this number, it generates a work order for me to service the aircraft before that component actually fails. So this industry is actually moving in that direction very rapidly. It's all about condition-based maintenance. Okay. So customers want a lot of different things. Asset life cycle management. And when you think about that, it boils down to that asset, that aircraft, it can last 50 years, if not longer, like I said. So they want to have that visibility of what that asset looks like today, what it looks like after 50 years, and at any time go back in time and see what that asset, what was installed on it at that day and time. You know, most of the time with aircraft, and you might not realize this, but most work on an aircraft is done on paper. Okay? And then it goes into a file cabinet, and that file cabinet can become many file cabinets upon many file cabinets upon many file cabinets based on the age of the aircraft. And the thing is, you cannot ever get rid of that data. By law, you cannot get rid of maintenance history for an aircraft. So you can have 20 different file cabinets of maintenance history for just one aircraft. So the industry is actually moving towards electronic data. And when they do that, you have to have that means to at least capture it, and then at any day and time, look back in history as to what was installed on an aircraft for regulatory requirements. There are software products out there that actually let you do that. I demonstrate one of those products for the airline industry that does it very well. But some of the other things that you see here is airlines don't just do their aircraft. They also own other assets. Okay? An airline will own hangars, cars, trucks, ground support equipment. They have all types of different assets that make an airline an airline. Okay? So in that case, they want always a system that will support not just the aircraft asset, but a multitude of assets. They're looking to have one system that does it all. One enterprise asset management system that will do everything that an airline does. Not just aircraft maintenance, but ground support equipment, cars, trucks, buildings, things like that. Okay. What else? Some of the unique out-of-the-box functionality that we sell is a J2EE product, a Java product. It's a web environment, and what we're also doing is we're moving to more of a point-of-sale type application. So if you want to buy the services of that software product, but not actually own it, because a lot of times these big companies, they don't want to buy software anymore because they don't want to have the infrastructure around to keep it running, like DBAs, system administrators, people like that. So what they're doing is they're actually going out and they're doing software as a service. Okay? And they'll basically just pay for it whenever they use it. And of course, then you have to then integrate into those other systems so that you can have the right telemetry data to maintain that aircraft asset. Okay? And it has to be a very simple, very easy, and a very methodical way of doing it through standard open architecture software products. Okay? So some of the other information here, looking forward, we talk about conditions, visualization, mobile, analytics, intelligence. Like I said, these aircraft are smart. 787 terabytes of information that come off the aircraft. But the biggest problem is that these airlines don't know what to do with that terabytes worth of information at this time. Okay. Condition. Now, I bring up this part here because this is kind of the area that I used to work in for engines, GE aircraft engines. This is actually a fan blade that did fail. But it's not always a good thing if it fails while you're actually flying in the airplane, right? I mean, that would not be good. You heard about the Qantas plane, Qantas A380, about 3-4 years ago. Took off from Sydney, and it was a Rolls-Royce Trent engine that failed in flight. Now, Rolls-Royce uses our software, and they use it as for the customer as a software service is what they do. And because what comes off of the actual engines is what's called pinging data. So data actually comes to Rolls-Royce automatically about the health of that engine, why it's in air. Okay, and they were able to then do a industry-wide service bulletin to rectify a problem that engine had with it. very quickly with our software product. But you'll also see that some of the other things is, when you think about these assets, these critical assets on board a plane, they're also starting to, in the industry, to put RFID tags on them for condition monitoring. And for the sensors, the history information, all that information is actually being built into the products now. Okay. Visualization. So when you talk about visualization, it's in this screen that you see here, it's more about where is my asset? And when I say where is my asset, in our case, an aircraft, where is it in the world? Because it doesn't have to just be at an airport. It could be in the air. It could be on approach to an airport. It could be anywhere in our network. So where is it physically? And like I said, these aircraft have GPS on board. There's a dispatch navigation system. They have all kinds of information. And that information actually helps us understand visualization of where the actual asset is. And then as a byproduct of that, lets us determine if a part is potentially going to fail, let's make sure we have that component in a close vicinity so that we can actually service the aircraft and get it turned around as fast as possible. Okay. Mobile. So a lot of things that are changing in the way of the mobile industry. This is kind of a slide on IBM, of course, because we build a lot of mobile applications. But the thing about it is that these devices, these iPhones, these Android tablets, the Android phones and things like that, the apps that go on them, they can either be connected through a cellular network, it could be a store and forward type of situation, it could be through Wi-Fi. There's all kinds of different things that are coming up into the industry that lets you as a consumer of that information fly on an aircraft, get your boarding pass, things like that. But it also helps the airline do their job. So a mechanic goes out onto the floor to work on an aircraft because they have it on their tablet, a work order that's been generated based on a condition that happened to the aircraft. So all this technology is there. It's coming very, very quickly, very quickly. Analytics. So in our solutions, we have all types of different things. So we have the analytics group at IBM. We own a product called Cognos, which is a BI reporting tool. We produce those KPIs that are required for the industry that help us understand when things are failing and what should not be failing, information like that. And these are all, standard products that IBM produces, and they basically have full integration to all of IBM others products. Okay? I work underneath the analytics group, but I actually do software demonstrations for what's called the Maximo product. Okay. The analytics, it's all about predictive asset optimization, increased return on asset, increased reliability and utilization. One of our customers is Caterpillar Engines. And Caterpillar produces large diesel engines in the industry for not just tractor trailers, but also big D9 bulldozers and things like that. So what they did was they actually, using the Maximo product, using condition-based maintenance, using the GPS on board, that D9 bulldozer, taking the engine data that is being captured on that bulldozer now, feeding it as a GPS stream into Maximo that says that coolant temperature is about ready to overheat. So we better shut down the diesel and send out somebody to fix it, find out why it's getting ready to overheat. So right now that's what they do with Caterpillar. Like I said, Rolls-Royce Engines does the same thing. They pull that information automatically through pings, and through condition-based maintenance, they can then call their customer and say, do you realize this is going on with your engine? So there are customers that are currently embracing the technology and using the technology, and it's only going to get, I guess the word is, it's going to get worse, right? Because, like I said, there's many terabytes of information that come off of those complex assets. So it's only going to get worse, but it's also going to be better, because if we have that information, we utilize that information, we can then do something with it and hopefully not have failures, which means better customer service. Okay. Like I was saying, intelligence on board the aircraft. On the far left-hand side here, you see some of the information that is on the aircraft right now. FMS stands for Flight Management System. I don't know if you've ever looked inside a cockpit of an aircraft, but they're pretty high tech with the CRT screens, and there's not a lot of old, dials anymore. It's kind of all, TV screens. They also have what's called ICAS, and that ICAS stands for Engine Alerting and Crew Annunciation System. And that ICAS system is monitoring the engines and telling us if there's any kind of problem with the engines. Okay. You have the navigation, you have IFAS. You then have on the far right-hand side some of the other technology that's on board the aircraft that tells us, the status of doors, lavatories, fuel, and things like that. And this helps them understand on the aircraft as to what's going on. But do they really embrace the technology of, well, I see something that's getting low, shouldn't it be nice if I could send that information to my Washington, D.C. airport where I'm getting ready to land and have them be ready before I get there with the part that I need, right? The information is there, so are we embracing that technology to actually move forward and make that happen? Okay? Because nobody wants to be delayed, right? I don't know of anybody but me, but I don't want to be delayed when I fly on an airplane. Okay, so this is just a brief, quick, changes are coming. Economic growth, passenger growth, globalization, technology improvement. We're all trying to go to that green operations, safety and security. Change is coming. Like I said earlier about the entertainment, just as a small thing, the entertainment systems on board aircraft, right? That change is coming. I don't know if it's happened a whole bunch in Europe, but in the States, it's coming really fast. Taking all of my nice entertainment off my plane and making me use my iPad, so it is coming. So in summary, and I think I'm going to hit my number okay, the Internet of Things. That Internet of Things is that connectivity of those complex assets on aircraft that then help me take information from the aircraft and let me do something with it. And that do something with it is usually helping me predict, as an airline, when something might fail. And am I going to have that component in the right area so that I don't have an AOG situation? Okay. It's a typical IBM question mark, so. Any questions? All right, so anybody know how much a 747 weighs? Come on. 747. 400? Close. A little high. Are we talking tons or are we talking pounds? It actually weighs 750,000 pounds at takeoff. Well, thank you.
Thank you very much.